Few elements on the planet can match the raw magnitude of wildfire. It has the ability to shape whole ecosystems, create its own weather, and power civilizations, or destroy them. Yet wildfires as we know them are changing. Across the planet, they're burning bigger and more often than ever before, incinerating millions of hectares of agriculture and infrastructure each year, killing livestock, wildlife, and people, and causing billions of euros worth of damage. But what is fueling these mega blazes? And how do we prepare for a future shaped by fire? In this series, we will interrogate the scientific workings behind wildfires, attempting to understand their complex behavioral patterns by exploring the physical and geographic factors that influence them, as well as the startling implications of climate change on global wildfire activity. Journey with us into the explosive world of one of nature's most indomitable forces, as we examine the anatomy of a wildfire. All life on Earth is predicated on a fine ecological balance. Everything works in symphony. Changes in atmospheric pressure between ocean and Earth create a weather system that drives the planet's seasons. And for 440 million years, since the first plants produced oxygen, the atmosphere has maintained just the right conditions to nurture all life in abundance. Yet in this time, fire has also irrevocably shaped the landscape. Whole ecosystems have adapted to survive and propagate out of the ashes. But it's only been 400,000 years since Homo erectus first mastered the art of making fire. This caused a crucial turning point in the cultural evolution of modern humans. With fire, our ancestors could venture into colder regions for the first time and forge stronger tools in the heat of a flame. Nowadays, whole cities are run off the energy from coal-fired power plants, while our automobiles and airplanes rely mainly on gasoline. Our entire lives are powered by combustion. But fire is a far older and more nuanced force than most of us understand. It is responsible for sculpting the planet we inhabit and molding the organisms we share it with. It is even responsible for shaping us. In this episode, we will take an in-depth look at what wildfire is and how it came to be. Traveling back in time to the earliest building blocks of planet Earth, and witnessing how each step in natural history would lead us incrementally to the present moment. One that has been formed in an age of fire. For the truth is, we live on a flammable planet, and it's only getting hotter. Wildfire. An untamed titan in its most brutal form, let loose on the world. Few forces of nature can rival its destructive power. It is a primordial expression of energy that has shaped the planet as we know it. Carving its signatures into the foundations of the very ground on which we stand. This wildfire has taken hold in a mountainous region outside the city of Cape Town, South Africa. It is an exemplar of wildfire in its most enduring form. Much like the perfect storm, there are certain conditions that can create the perfect fire. Strong winds urge the flanks of flame onwards. As they climb through inhospitable landscape and devour the dry terrain. Each wildfire is unique, an expression of its surroundings and conditions. Capable of change in an instant, and always carrying fatal potential. The task that lies ahead of the team of firefighters is a daunting one. Wildfires like this one hold an ever-present capacity for catastrophe. In order to curb the destruction wrought by the inferno, they will need a deft understanding of the makeup and workings of megafires in their natural setting. They will battle the blaze through the night, knowing they are facing one of the planet's oldest forces. This is raw elemental power in its ultimate form. But it hasn't always been here. There was a time when fire didn't exist on Earth, and things looked very different. To understand the beginnings of our flammable planet, we have to look way back in time, to a most unexpected place and a most unassuming entity. These are stromatolites. They are the oldest fossil evidence of life on planet Earth, dating as far back as 3.7 billion years. These ancient structures are formed along the intertidal zones of oceans by cyanobacteria. They may not look like much, but they are vital to the narrative of how our world came to be. And what makes them so important to the wildfire story has to do with the process in which they were formed. The cyanobacteria in stromatolites were the first organisms to perform oxygenic photosynthesis. When they did this, they increased the amount of oxygen in the Earth's atmosphere. It took about 1 billion years for this oxygen production to make any significant difference. But when it did, the change was immense. We know it as the Great Oxygenation Event. And because of it, our planet became shrouded in oxygen, allowing all of the organisms that we know today to exist. And this was a crucial step in the evolution of fire. On a chemical level, fire is an exothermic reaction commonly known as combustion. It is an energy-releasing type of oxidation that needs 3 things to take place: fuel, heat, and oxygen. These combine to form what is known as the fire triangle. After the Great Oxygenation Event, the planet had enough oxygen for fires to spark. But it was not until 440 million years ago that the third arm of the fire triangle, fuel, would be fulfilled. This was called the Devonian period, and it was then that wood first appeared on the planet. Plants first developed wood as a means of transporting water. Later, it would become a support structure for trees. When wood arrived, conditions were perfect, and for the first time in history, a fire broke out. And it's been raging ever since.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen. All for free. No subscription required.
It's only in wilderness areas that we are able to get a peek into how fire has functioned through the ages. It is here that we can witness how it moves and interacts with the landscape, disintegrating and reshaping the natural materials it encounters. This wildfire has burned through into a second day, devouring much of the South African mountainside. The chief reason for its size and ferocity is the sheer volume of dry, woody vegetation that it has to burn. Wood and fire are the ultimate partners in this primal dance of earth and element. Wood combusts when it reacts with oxygen to produce heat energy. Only gas has the ability to combust. So for fire to occur, the wood needs to be heated until the point that it releases gas from its surface. When a solid object is heated until it becomes a gas, it is known as pyrolysis. When wood reaches 150 degrees Celsius, the heat decomposes the cellulose material that makes up the wood, which then releases pyrolysis gas. When these gases become hot enough, the molecules break apart into fragments that bind with oxygen in the air. They form hydrogen dioxide and carbon dioxide molecules, otherwise known as fire. For the firefighters, the job is to break the fire triangle. If they can interrupt the flow of oxygen, heat, or fuel, they will defeat the blaze. Their first mission: target the fuel. Without fuel, there can be no fire. The team has opted to try and physically remove the woody shrubs ahead of the fire's path. For the fire cannot burn what is not there. The topography of the land is an important consideration when targeting the fuels, because this influences the amount of solar radiation received. Hotter fuels burn easier, because half the job has been done before the fire has even arrived. The direction the mountain is facing, known as the aspect, is crucial in this regard. In the southern hemisphere, slopes with a northern aspect create the most devastating fires because they receive the most sunlight. The sun has the ability to preheat the ground, priming it to a point where even the slightest provocation can cause catastrophe. Today, the situation is at its worst. Waves of fire 4 stories high whip across the road, engulfing whole swathes of forest. For the firefighters, almost all the odds are stacked against them. This wildfire is too large and widespread to fight head-on. And as it consumes everything in its path, it only grows in fervor and aggression. But understanding the apocalyptic force of fire is only one side of the story. Wildfire is equal parts destructive terror and creative artisan. We owe planet Earth as we know it to fire. Fire-prone ecosystems cover 40% of our land surface today. Since fire first scorched the Earth, species began evolving to use its destructive potential as a means for furthering life. This area, known as the Southern Cape of South Africa, is one of the most fire-prone places on the planet. In the last year, 91,000 hectares of land have been razed to the ground. The biomes that exist here carry with them a multitude of adaptations that use fire's power as an agent of creation rather than devastation. The predominant vegetation type is called fynbos shrubland. The fynbos biome consists of approximately 7,000 species. And many of these have ingenious techniques for using fire to flourish. Following the desolation of a wildfire, new growth explodes in abundance from plants known as fire ephemerals. Seeds that have remained dormant in the earth, sometimes for years, suddenly emerge and begin anew. There are many different ways that plants use fire to create new life. But there is one particularly inventive method that has remained a mystery to scientists for years, until very recently. And the secret lies in the smoke of burning leaves. As leaves burn, special chemicals known as characins start to form. These chemicals don't occur naturally within the plant, but are only produced when the carbohydrates in the plant are heated. This releases characins in the smoke. After the fire has subsided, the characins seep into the soil where dormant seeds lie. When the characins reach these seeds, they trigger an alarm bell that signals it is time to germinate. As they do so, the new seeds burst through the ground and flower, leaving more seeds behind to wait for the next fire to trigger their awakening. In this way, burning plants send a smoke signal to the next generation, informing them that their long sleep is over and that it is time to breach the surface of the earth. Environments that are adapted to thrive in the presence of fire are more disposed to burn. And this is another reason that this particular fire is moving so ferociously. It has taken hold in 3 different vegetation types that are naturally primed to combust. The main body of the fire is burning in fynbos, but in its southernmost flank, it has crept into a pine forest. These trees thrive in heavy fires. The flames contribute to spreading pine seeds faster because this is part of their propagation strategy. Pine trees originate from the northern hemisphere and are ubiquitous in North America. The US has suffered a spate of catastrophic fires in recent years. Wildfires have caused an estimated $5 billion worth of damage in the last decade. On average, more than 100,000 fires burn across the country every year. And pine has a big role to play. Pine cones form a thick shield that encases the tree's seeds inside. The fire aids the trees in two ways. Firstly, it breaks open the cones, releasing the seeds into the earth. And secondly, it removes any obstructions to sunlight that other surrounding trees would have otherwise caused. This strategy allows young pine trees to grow without any competition. Fire is a critical aspect of their evolution, so they tend to spark easily. And further to the east, the fire has latched onto a stretch of eucalyptus forest. There are more than 700 species of eucalypts in the genus, all of which are designed to burn. Eucalyptus trees come from Australia, a country plagued by devastating and deadly fires. A recent surge of fires leveled 2 million acres of land. And eucalyptus trees are often at the base of these conflagrations. In Portugal, a quarter of all of the country's forested land consists of eucalyptus plantations, because the tree's pulp is one of the country's biggest exports. But when 18th century botanists first introduced the species, they could never have known its fatal legacy. Recently, a single scourge of eucalyptus fires killed more than 100 people and caused €1 billion worth of damage. Fire is an essential part of the life cycle of the eucalyptus tree. Their leaves and sap are highly flammable. When fire catches in the trees, the bark fuels the flames, encouraging them to climb up to the crown. After the fire has decimated the landscape, the burnt seed capsules open up and thrive in the ash-rich soils. This single South African wildfire is being propelled by 3 separate forces of combustion, organically engineered from 3 opposite corners of the globe. It is a microcosm for the global wildfire story. And it's only via a view of the planet that wildfire's true significance can be understood. In recent years, Indonesia, Canada, America, Chile, South Africa, and Russia have all been wrecked by major blazes. Whilst the number of fires in Europe has increased by a full 40%. Indeed, if we were to step outside and look at the planet from outer space, we would see that the whole Earth really is on fire. While there are many reasons for this that pertain to human activity, one reason that cannot be ignored is the fact that fire is, at least in part, a natural state of planet Earth. And this is because the conditions that allow fire to exist are also the very same conditions that allow us to exist. Fire has been present on planet Earth for more than 400 million years. It has crafted and shaped the world as it has burnt it. As we track fire through the ages, we can see how it leaves its imprints on all of the organisms that have evolved to thrive in the flames. But there is one very modern life form that has an ambiguous relationship with fires. Us. The control of fire by early humans changed the course of our species forever. The earliest evidence of humans using fire emerges from a cave site in South Africa, dating back 1 million years ago. Fire would allow our ancestors to migrate from Africa to colonize the far colder European continent 790,000 years ago. Humans then moved to the top of the food chain because we could burn whole landscapes. Fireplaces and ovens emerge in the timeline 200,000 years ago. By the Iron Age, we began marrying fire and metal. This would lead to our early forges and factories. By 1860, the Western world became entirely powered by coal. Fire then became an agent of our wars. Fire gave rise to our cities. Fire allowed us to leave the earth and step out into space. Without fire, we would have been unable to power the human brain. Fire even changed the very structure of our genome forever. It prompted our guts to be smaller and allowed our heads to be bigger because we could cook food for the first time. Being around smoke also forced a genetic mutation in modern humans that allowed us to metabolize certain toxins at a safe rate. This evolutionary advantage is only found in Homo sapiens, and it is a direct result of being around fire. As humans, we owe what we are to fire. But our relationship with it is far from one-sided. There are various forms of fire, and while we have been able to manipulate and master many of these to our benefit, there is one that we have never been able to control: wildfire. Ever since the first fire brigade was established in Rome in 6 AD, humans have been trying to put out fires in as much as they have been lighting them. Firefighters now have a range of techniques built on centuries of knowledge with which to face this ancient force. Handheld beaters are effective at smothering the fire's oxygen supply. The firefighters have to fight shoulder to shoulder, otherwise they will fan the fire rather than suffocating it. Water is an effective firefighting mechanism because it targets the fire's heat supply. This is because it takes a tremendous amount of energy to heat water up. A single liter of water absorbs 3 megajoules of energy before it turns into steam. By wetting the ground, firefighters force the fire to expend massive amounts of energy to heat its fuel source to a temperature that it can ignite. And when firefighters target their hoses onto burning substrate, the fire has to work harder to retain enough heat to keep its combustion reaction going. How firefighters attack a fire depends on a number of variables. The size of the flame, the type of fuel being burnt, the topography of the land, and the atmospheric conditions all play a major part in forming a fire suppression strategy. This wildfire is proving itself as a worst-case scenario in all major considerations. A fire's best topography is densely wooded, steep and mountainous, the worst possible terrain for firefighters to do battle in. And it is here that the wildfire is thriving. But aerial support is a massive ally in our battles against the blazes. Humans have been using aircraft to try and put out fires from as early as the 1920s. But it was not until the 1950s that they became fully functional fire suppression tools. Modern firefighting helicopters are equipped with buckets that can hold up to 3,000 liters of water. These are filled at a nearby source and then moved to the battle zone. Aircraft are most efficient at combating the fringes of the fire. This is because they are more effective on fires that are still small and growing. Spotter planes are used to orbit the fire and relay key information to the control base. They act as an eye in the sky, which is often a vital help in coordinating an attack. When a fire has grown to a considerable scale, the aerial combat strategy is one of indirect attack. Aerial firefighters surround the fire and outflank it. As they drop retardant on the ground, they box the fire in, making it more difficult for the inferno to grow. Even with all of the advantages that airplanes and helicopters provide, they cannot win the war by themselves. Big blazes require a unified attack on all fronts in order to be curtailed. And it is only through the precise coordination of both aerial and ground forces that this particular wildfire can be faced. The firefighting team has identified a key point at which to attack the enemy. In order to try and outmaneuver the fire, they need to defeat the growing fire line on the top of the mountain. Helicopters are used to transport the ground troops to this inaccessible battlefield. If the flames are below 1 meter high, the fire may be controlled directly at the head. The fire line is comprised of a light fuel load, which means that the most effective form of attack is hand-to-hand combat. Highly targeted physical strikes are used to extinguish sections of the growing line. Step by step, they remove the fire's fuel sources, whilst simultaneously smothering the flames. The stand on the mountain has been successful. But this fire has taken its toll on the landscape. The once fertile mountains are now an apocalypse of char and ash. And not everything that has been burnt will grow back. If a fire burns above 300 degrees Celsius, it incinerates all of the organic matter in the underlying soil. Meaning that even though the flames may be out, anything that was once living has now been scorched. The firefighting team further down the mountain has a far more daunting enemy in front of them. Fires that are this well developed become near unstoppable juggernauts. When they reach this size, they start to feed off the processes they themselves have created. As hot air rises, it is replaced by cooler air that is sucked in from the surrounding area. This begins the circle of reinforcement. Increases in the wind intensify the fire, which increases the wind, which further intensifies the fire. Fires of this magnitude even generate their own weather. Pyrocumulus clouds. These form when the extreme heat from the flames forces air to rise rapidly. As the fire burns vegetation, it causes the water inside it to evaporate into the rising air, where it condenses around smoke particles in the atmosphere above. When these clouds form, intense burning and an unpredictable spread of fire in all directions is likely to occur. It has now become the ultimate wildfire, capable of creating its own climate and spreading by its own volatile will. These infernos function outside of the predictable patterns of ordinary fires. As the smoke plumes increase, the firefighter's job gets progressively harder. The smoke obscures their vision and obstructs their breathing. As the team battles through the haze, trying to stall the fire, it climbs ever higher through the mountains. It is the Earth's gravitational pull that dictates how fire spreads. If you were to light a fire in zero gravity, it would form a sphere. But owing to gravity, the hot gases in the flame are less dense than the surrounding air, so they rise towards lower pressure. This places the fire on a continuous upward trajectory, meaning that the nighttime fight is going to be a difficult one. When the sun dips, the true magnitude of the enemy ahead is revealed. As dusk arrives on the battlefield, the team prepare themselves for the final stand in the mountains. Fighting fire at night is a different story altogether. The ability to judge distance is severely compromised. The size of the fire becomes overestimated, and the proximity between yourself and the flame becomes underestimated. And in firefighting, there is a very crucial reason why this shouldn't happen. The killing zone. Radiant heat is responsible for killing most people in fire tragedies. Heat moves through space as energy waves. It travels in straight lines at the speed of light. This is why, when facing a fire, you can only feel heat from the front. And as you get closer to the fire, the heat increases. The killing zone is an area in front of the fire, where the radiant heat will be enough to kill a firefighter. It can be calculated as the height of the flames multiplied by 3. And it is here that the team must do battle. When firefighters enter the killing zone, the most important thing is that they don't panic. Panic consumes energy, and that can lead to death. Another important consideration is that the firefighters stay together. Most firefighters who die alone. Nearly half of those that perish in the line of duty succumb to heart attack, caused by the human body being unable to cope with the radiant heat energy of fire. The team works tirelessly to battle the blaze, but this fire has become too dangerous. They are forced to retreat. Wildfires that are this big cannot be fought from within, and they cannot be beaten by human hand. When fires reach this intensity, they become more powerful than all of our collective suppression tools combined. If the heat energy reaches beyond 70 degrees Celsius, even 1 second of unprotected exposure to the flames is enough to char human skin instantly. Water, too, is useless because it turns to steam before it can affect the fire's heat supply. And under these circumstances, it is too dangerous to fly planes and helicopters at night. When a fire reaches this size, the only thing that can defeat it is fire itself. Backburning, also known as counterburning, is the principle of using fire to fight fire. But conditions need to be absolutely perfect before it's even attempted. If the wind is not blowing in the correct direction, or the topography of the targeted hill isn't perfect, the backburn could create even greater catastrophe. With the wind fanning towards the blaze and the main fire moving at a slower pace down the mountain, the firefighters decide to take the carefully calculated risk. Backburning is another way of targeting the wildfire's fuel source. By the time the wildfire has descended the mountain, the man-made fire would have burnt everything in its path, leaving nothing for the wildfire to consume. With the wind fanning it, the backburn moves quickly up the hill, racing to meet the oncoming wall of fire. And just like that, peace finally falls across the charred South African landscape. When fire first sparked on the surface of our planet, everything changed. A force emerged that could topple the tallest trees, level mountains, and leave whole landscapes barren. This force did something unique, something that nothing else had been able to do before. It synthesized its surroundings by taking everything and making it part of its own chemical reaction. Through fire, the oxygen in the air and the surrounding organisms were combined on a molecular level and expressed as heat and light energy. This reaction was powerful enough to break apart whole entities and reconstitute them in a new form, taking multiple different elements and making them one burning whole. And as this happened, the world began to change. Living organisms started using this destructive power as a means of creation. Wildfires leveled entire ecosystems to dust, so they could be born again from the ash. Through the ages, it has been an engine for evolutionary change. This has been most recently evident within our own species. Fire has enabled massive technological advancements, allowing us to power ourselves from antiquity to modernity. But in its unchained, untamed form, wildfire is too great for all of our technology. With fire, we encountered one of nature's most brutal forces. One that we couldn't always domesticate, one that didn't always bend to our will. The story of wildfire through the ages is the story of our planet as we know it. And ultimately, it is the story of us. But wildfire remains a constant threat to our modern civilization. And the evidence is clear. Things are only getting hotter.
Today's weather, hot.
In the next episode of Anatomy of a Wildfire, we will take a look at fire and modernity, delving into the nuances of what happens when humans and fire share boundaries, feeling the heat of the flames on the doorsteps of our modern urban settlements. Few elements on the planet can match the raw magnitude of wildfire. It has the ability to shape whole ecosystems, create its own weather, and power civilizations, or destroy them. Yet wildfires as we know them are changing. Across the planet, they're burning bigger and more often than ever before, incinerating millions of hectares of agriculture and infrastructure each year, killing livestock, wildlife, and people, and causing billions of euros worth of damage. But what is fueling these mega blazes? And how do we prepare for a future shaped by fire? In this series, we will interrogate the scientific workings behind wildfires, attempting to understand their complex behavioral patterns by exploring the physical and geographic factors that influence them, as well as the startling implications of climate change on global wildfire activity. Journey with us into the explosive world of one of nature's most indomitable forces, as we examine the anatomy of a wildfire. All life on Earth is predicated on a fine ecological balance. Everything works in symphony. Changes in atmospheric pressure between ocean and Earth create a weather system that drives the planet's seasons. And for 440 million years, since the first plants produced oxygen, the atmosphere has maintained just the right conditions to nurture all life in abundance. Yet in this time, fire has also irrevocably shaped the landscape. Whole ecosystems have adapted to survive and propagate out of the ashes. But it's only been 400,000 years since Homo erectus first mastered the art of making fire. This caused a crucial turning point in the cultural evolution of modern humans. With fire, our ancestors could venture into colder regions for the first time and forge stronger tools in the heat of a flame. Nowadays, whole cities are run off the energy from coal-fired power plants, while our automobiles and airplanes rely mainly on gasoline. Our entire lives are powered by combustion. But burning fossil fuels releases heat-trapping gases into the atmosphere, which in turn increase the temperature of the planet. We know this phenomenon as global warming, part of changing climates that bring unprecedented heat waves and devastating droughts. All of this creates excellent conditions for wildfires, which are fast becoming a central concern for growing populations living on the fringes of urbanized areas. Indeed, this most ancient of forces is a very modern problem. Therefore, understanding how wildfires work and the protocol for protecting against them is of paramount importance. For the truth is, we live on a flammable planet, and it's only getting hotter. Never before has Earth supported such a large human population. And as our numbers grow, so too should our concerns about wildfires. Continued human development requires space. Spreading cities and towns extend the borders between natural and developed areas, which are called urban wildland interfaces. These are defined as the transitional zones between urban development and unoccupied or wild land, and it is here that the threat of wildfires is most pronounced. This is due to the proximity of flammable vegetation and the increased risk of unintentional ignition of wildfires by humans. Yet urban wildland interfaces are some of the fastest growing land types in the world. In California alone, 11 million people, or more than 25% of the state's population, now live in these high-risk zones. And in Cape Town, South Africa, a city almost surrounded by mountains, there's no shortage of urban wildland interfaces. Cape Town is located in the Western Cape of South Africa. And like the Mediterranean basin, Southwest Australia, California in the United States, and Chile in South America, it has a Mediterranean climate. This means hot, windy summers with little or no rainfall. Fire weather. This, coupled with vast areas of urban wildland interface, make it a city inadvertently designed to burn. And today, city firefighters have received a call to action. A fire has started on Table Mountain, a national reserve and one of the 7 wonders of the world. Table Mountain holds some of the greatest floral biodiversity on the planet, with 2,200 endemic species of plants. all of which are ready to ignite in the dry summer heat. The fire was started on the northeastern slope of the saddle between Table Mountain and the buttress of Lion's Head. The battle has begun below the road, which acts as a natural control line. But there's another element to contend with. It's always a dangerous variable in the fight against wildfires. A strong breeze pushes the blaze towards the sidewalk. Wind is a primary determining factor in fire behavior because it delivers more oxygen to the flames and increases the intensity of the blaze, as well as dictating the direction in which it burns. Wildfires can exhibit extraordinary behaviors under the right circumstances, like spreading without the touch of a flame. This happens through a process called radiation, which is the transfer of heat through short energy waves that preheat and eventually combust exposed fuels. And that's exactly what happens here. After extreme preheating, radiated heat whips over the road and carries the blaze up and over the control line, breaking through the firefighters' first line of defense. The fire is now climbing up the front of Table Mountain. The inferno gains momentum as it goes. Yet it's not just the wind causing it to pick up pace. As a rule, wildfires burn significantly faster uphill. This is due to the preheating of the material in front of the blaze, which makes it combust more readily. But the most important factor influencing the intensity of a wildfire is how much fuel is available to burn. The slopes of Table Mountain are packed with dry grasses and shrubs, and dotted with stands of large pine trees. Excellent fuels for a raging fire. Understanding how wildfires move up slopes and through different fuel types helps firefighters predict fire patterns. Right now, that's exactly what these firefighters must do. Because with houses nearby, this blaze has the potential to become catastrophic. The fire is now so close that residents wet their roofs down as a last line of defense. As the threat of injury through smoke inhalation increases, the neighborhood is evacuated. Luckily, support swoops in from above. Firefighting helicopters can carry up to 3,000 liters of water in a single load of their specially designed water buckets. They dispatch these water bombs on hard-to-reach parts of the blaze, making them some of the most indispensable weapons in the fight against wildfires. With each targeted drop, water rushes over flame, dousing whole swathes of the burn. But why is water so effective as a fire extinguisher? To answer this, one needs to first understand how water is formed. On a molecular level, water is produced through oxidation when hydrogen atoms combine with oxygen atoms, creating H2O. This means that water is actually made through a process of combustion, so it cannot burn again. Water is also exceptionally good at absorbing heat, and it takes a lot of energy to transform it into steam. When water comes into contact with a flame, it rapidly strips away heat, eradicating the blaze more effectively than almost anything else. Through a combination of tactical ground and aerial efforts, the blaze has been brought under control. Now the mop-up team moves in to finish off the battle by snuffing out any lingering hotspots. Severe damage to much of the surrounding vegetation was unavoidable. Yet luckily, no houses or lives were lost. The firefighters will remain on the scene for several hours after the last flame has been extinguished. This protocol is in place to guard against any unexpected flare-ups from changes in weather or unburnt fuel sources. These stoic old stone pines have remained standing through it all. They are in fact fire-adapted themselves, keeping their precious leaves safe from flames by holding them high in their crowns. But not all escaped unscathed. Some have been reduced to smoking ash pits. Deep holes in the ground filled with hot embers, where the incinerated roots of the trees still burn. These pits are one of the dangers of fire-ravaged landscapes, and many a firefighter has sustained serious injuries stepping into them. The brave men and women who fought this fire can congratulate themselves on a well-deserved victory. Fatigued yet triumphant, they finish up a day in a life that few would willingly choose. But a firefighter's job is never done in fire season. And not far from Table Mountain, another neighborhood faces a runaway blaze. It started on the urban wildland interface between the houses and the mountain. Firefighters respond immediately. They understand the potential threat of the fire jumping the road and tag team it, attacking the head of the blaze with high-powered hoses. These hoses can spray well over 1,000 liters of water per minute and are perhaps the most iconic and indispensable tools of the firefighting trade. But as the fire ignites more of the tall trees, it becomes clear that water alone isn't going to be enough to turn the tide on this blaze. Yet the firefighters have another substance at their disposal that could be considered a flame-retarding trump card. And it's more often associated with bath time than firefighting. These helicopters are loaded with thousands of liters of specialized flame-suppressing foam. The foam is far more efficient than water in extinguishing flames because it has excellent expansion properties, allowing it to cover a wider surface area than water. This increased surface tension also gives it a longer drain time, which makes it even better at wetting the unburnt fuels surrounding the flames. And it's lighter, so more can be carried and dropped in a single load. Overall, this makes fire-suppressing foam a highly effective weapon in the fight against wildfires. and it's helped firefighters protect the people and homes of this neighborhood. But not all communities are as well protected from wildfires. This informal settlement in Cape Town is one of the most vulnerable types of community on the urban-wildland interface. It's a manifestation of rapid urbanization and massive socio-economic disparity, which can be seen across the world, especially in developing countries like South Africa. The reason informal settlements are at such risk from wildfires is due to an almost complete lack of infrastructure to deal with such disasters. Fires like this one, which started from an unknown cause in an unattended home, are no stranger to the township. They're a terrifying reality. This is the third fire here in 2 years, and it's by far the worst. There are several factors that make fires especially deadly in informal settlements. The first is that the houses are built out of materials that are often very flammable. They are also built extremely close together, allowing for the fire to spread rapidly from house to house. This means a blaze of mammoth proportions, burning too large and aggressively for aerial suppression to make any discernible difference. Soon the fire has enveloped large swathes of the township, and the residents are forced to evacuate. For firefighters, blazes in informal settlements can be extremely challenging to fight. The roads are narrow and impede access, and burning debris and red-hot metals create dangerous hazards. Despite all of this, they persevere. Eventually, the blaze is brought under control. In a short time, it's done incredible damage. More than 500 structures were lost in the fire, leaving thousands homeless. For most, there will be no insurance coverage or replacing what was lost. With so little to begin with, starting again will be harder still. It's not just cities that hold fire-prone urban wildland interfaces. Globally, some of the most high-risk spaces are agricultural lands. And when farms burn, the consequences are both costly and far-reaching. In the US, damage to farms from wildfires costs more than 100 million euros each year. And it's estimated that agricultural fires are more expensive than any other type of fire by 9%. The reason wildfires on agricultural lands are so costly is because they have a twofold effect. The first loss is the commercial value of the crops being burned. And when crops burn, it's a lot more than just the harvest that goes up in smoke. It's the time and labor required to cultivate them and the loss of income that would have come from selling them. The second loss is of property and farming infrastructure. Once fire has licked the land, the soil is damaged, which compromises any future crops and causes serious economic consequences. There is no denying that around the world, wildfires are becoming an increasingly urgent problem for rural and urban populations alike. In 2018 alone, there have been more than 58,000 wildfires around the world, which burnt a staggering 3.5 million hectares of land. And in the summer of 2018, for the first time in history, there was a fire in almost every country in Europe, with the top 10 countries experiencing a combined total of more than 5,400 wildfires between them. All of the statistics point to an undeniable rise in wildfire activity around the world. And scientists think they know why this is happening. Climate change. It's a simple enough equation. As climate change accelerates, it causes a long-term rise in temperature as well as a drop in rainfall. In practical terms, this means as climates get hotter and drier, they become more susceptible to intense wildfires. But in a world of fake news, what proof do we have that climate change is real? The scientific evidence is unequivocal. The 5 hottest years in human history have all taken place since 2010. Oceans are warming faster than ever before, and Antarctica lost about 127 billion tons of ice every year between 1993 and 2016, with that rate tripling in the last decade. As we have pushed the Earth's temperatures up, the global fire season has increased by nearly 20% over the last 30 years. A chief agent behind this unnerving rise in temperature is carbon dioxide, and it comes from almost everything we do. The machines we use, the trees we fell, the lights we power, the coal we combust. As carbon dioxide is released into the atmosphere, it traps the heat from the sun while still letting light waves through. This is called the greenhouse effect, and we've known about it since 1896. It's one of the primary driving forces behind global warming, and tangible proof of the alarming changes humans have wrought upon the Earth in only a few hundred years. With the rise in the use of fossil fuels, the industrialization of agriculture, and the urbanization of more than half the world's population, in a short time, we've changed the very workings of the planet. In our tireless pursuit of annual, profitable growth, we've put the very system that supports human life at risk. But the Earth also has forces of its own, fighting to keep its delicate balance intact. And the hero of this story isn't something that you would expect. This seemingly innocuous clump of mud stands between us and complete ecological disaster. And its name is peat. 10,000 years ago, the last great ice age ended. As the glaciers released their icy grip on the land, a new biome entered the world, one that would change the planet forever. A very particular type of moss called sphagnum began to take hold in some of the shallow depressions where the glaciers once stood. And when it did, a peculiar phenomenon occurred. The melting ice filled certain catchment areas with water, and due to poor drainage, this water was low in oxygen. Sphagnum's large cell structure allowed it to absorb this water like a sponge. Because of the anaerobic conditions surrounding its growth, when the moss died, it didn't fully decompose. And this is how peat came to be. As more surrounding organic matter died, it began to accumulate in the waterlogged moss beds. When more bodies of plants were added to the pile, the stunted rate of degradation meant that they also became trapped in a state of partial decomposition, forming a curious biome of organic matter, half alive and half decomposed, with one foot in the grave and the other clinging to life. It has taken thousands of years for peat to form in swamps, and its importance cannot be overstated. Peatlands are the world's largest natural terrestrial carbon store. They cover only 3% of the globe's surface, but they remove over 350 million tons of carbon dioxide each year, storing more carbon than all other vegetation types in the world combined. Throughout history, as we have been pumping CO2 into the atmosphere, peat has been continually drawing it back. There is nothing else on planet Earth that is so effective at holding these dangerous gases. Year after year, century after century, making it the hero of the global warming story. But if you involve farming and fire, this humble hero swiftly becomes a supervillain. This smoldering landscape is what it looks like when good carbon sequesters go bad. Farmers compromised this once pristine South African peatland when they diverted the flow of a river, causing the peat to dry out. When peat dries, millennia of stored carbon becomes vulnerable. If the peat then burns, all of that carbon is released into the atmosphere. Peatland fires are a unique and extremely difficult form of wildfire to fight for one simple reason. They happen underground. This one started after an above-ground wildfire passed through the area and ignited the ancient fuel source below. For firefighters, the only way to see the subterranean inferno is with modern technology. Using drones, it's possible to get a bird's-eye view of the wetland, complete with a sense of where the river runs through it and the proximity of a nearby road. But it takes thermal photography to pick up the heat signature of the fires burning below the surface. These infrared images show what was invisible to the naked eye, that the peat fire is still very much alive. Peatland fires can burn for months due to peat's extremely high fuel load, steadily releasing toxic fumes and making them economic and ecological disasters. In Indonesia, a large peatland was recently drained to make way for agricultural land. The resultant peat fires cost more than 14 billion euros in damage. The fires also released more than 1 billion tons of CO2 into the atmosphere. That's more than Germany's entire carbon dioxide output for a whole year. Elsewhere in the world, the smoke from recent peat fires in Moscow killed an estimated 3,000 people. Peatland fires burn long and slow, far out of reach of traditional suppression methods like fire hoses or helicopter drops. This peat fire has persisted stubbornly for months on end, devouring so much underground peat that it's actually caused the ground above to collapse. And it's spreading steadily closer to the nearby road. Should the fire reach beneath the tar, the whole thing will crumble into the inferno beneath. In the face of imminent disaster, the latest peat fire suppression technology has been brought in. These spiked rods were first debuted during the Indonesian peat fire crisis and are uniquely designed to attack elusive peat fires. They reach deep below the surface and inject high-pressure jets of water through the cracks, snuffing the fire out in the trenches. Like all trench warfare, the work is blind and so requires adept tacticians. The team targets specific areas with higher thermal heat signatures. It's hot, dangerous work that requires protection from the noxious gases. But it's an important turning point in a firefighting saga that's lasted months. Finally, using modern technology and old-fashioned perseverance, firefighters are putting an end to this potential catastrophe. For this peatland is one of South Africa's last. Not only does it regulate the functioning of the entire surrounding ecosystem, but it also sequesters large amounts of carbon from the atmosphere, playing a vital role in Earth's battle to retain balance in the face of a climate crisis. Technology has been indispensable in helping us understand the role of wildfire on Earth. It shows us that wildfire is an integral part of the planet's system as a whole, and that human activity has changed the global fire regime. But it also helps us predict when and where the next wildfire could strike. Tools like the Advanced Fire Information System, known as AFIS, and NASA's Global Fire Weather Database help governments and firefighting organizations study wildfire behavior from above. By analyzing weather data such as wind speed, temperature, and humidity, firefighting organizations can identify potential fire conditions and determine the fire danger index of a place at any given time. This makes predicting potential wildfires easier and allows officials to better mitigate fire risk to society. But even with increased capacity to monitor and assess fire behavior, technology can't protect against human error. Forensic investigations into the causes of wildfires have given us a shocking statistic. 85% of wildfires are caused by humans. When human fire ignitions are combined with drought and fuel buildup in fire-prone areas, it can spell disaster for communities in the danger zones. All of these factors are at play in the tranquil coastal town of Betty's Bay in South Africa. The tall, steep slopes behind the town are covered with dense vegetation. Which, after the most severe drought in recent history, is tinderbox dry. It's also the peak of summer, a time when temperatures soar. Setting, weather, and fuel are primed. All that's needed is a spark to start the blaze. And that comes from human stupidity. The fire was allegedly started when a man shot a flare into the air above the mountainside. When it fell to earth, it quickly ignited the dry fuel load. In a matter of hours, the fire had climbed across the side of the mountain, precipitating an immediate response. With no suitable water sources in the area, the firefighters cannot rely on helicopters and must use hand-to-hand combat against the growing flames. They're employing customized tools called fire beaters. These beaters are made of industrial-strength rubber and are designed to cut off the oxygen flow to the margins of the burn with each swing, extinguishing it bit by bit and allowing the firefighters to gain ground. But beating a fire into submission isn't easy, especially because the flaming plants are fynbos, a vegetation type designed to burn. The intricate shrubs have dense foliage and are packed together. And the ground is lined with dry plant matter, drastically increasing the fuel load. The pleasant smells the plants normally give off on warm days are from flammable oils in their leaves. Sweet-scented geraniums and boohoo's now burn with a startling readiness. All of these adaptations are in anticipation of fire, which will act as a crucial trigger that stimulates the germination of dormant seeds and clears space for bulbs buried below. This is the paradox of biomes evolved to burn. Fire is an essential part of the ecosystem, and this fynbos region actually needs to burn. But the town below must avoid a fire at all costs. And just as the firefighters seem to be winning ground against the blaze, nature's greatest wildfire ally tips the scales. Wind can single-handedly change the face of a wildfire. It can transform it from sedate and slow-moving to roaring menace that tears across the land. In Betty's Bay, the wind has picked up to speeds in excess of 100 kilometers an hour. And it has changed direction, now blowing the blaze back towards town. These extreme conditions are unusual for the area at this time of year. And it's the very worst thing that could happen to a small town in the midst of a fiery battle. First comes the apocalyptic blanket of smoke, bringing with it hot ashes and blistering embers. When the fire hits, there's little anyone can do. Whipped into a hungry frenzy by the jet stream of wind, it devours houses whole, gutting them from the inside with flames that burn at temperatures exceeding 600 degrees Celsius. It's a spectacle of cataclysmic proportions. For many, Like this man and his family, the only thing left to do is to stay as far away from the inferno as possible. They take refuge in the shoreline close to the sea, where they will be safest.
I couldn't grab my suitcase.
Across the town, fire rages. All must flee as their homes and possessions perish.
Get in, get in, get in. You're right. Get in, get in. Get in.
Eventually, after days of burning, comes respite from above. Rain brings a small relief to the remains of the ravaged town. The Betty's Bay fire of January 2019 lasted 14 days. It incinerated 12,800 hectares of pristine vegetation, leaving scars along the mountainside. "41 residential homes were completely destroyed. Another 29 homes were severely damaged, with many people unable to salvage anything. Yet in time, nature's balance will prevail on the hillsides outside the town. Regeneration will come slowly to the area, bringing new life from the ashes. Indeed, many of the plants here have been waiting for years for the fire to trigger their new growth cycles. But the tragedy of the lost town speaks directly to the challenges facing all of us. As the world continues to urbanize and climate change exacerbates the severity of droughts and extreme weather conditions, the risk of massive wildfires increases exponentially. And it's become clear to wildfire experts that when mega wildfires start, they're practically unstoppable. No amount of water or flame-suppressing foam will stop us from entering a new era of wildfires. Where the conflagrations will be bigger, more intense, and more frequent than ever before. Therefore, our best recourse is a proactive approach that looks at how we can start living alongside wildfire, acknowledging it as one of nature's most dominant and essential forces. for the future of our flammable planet will undoubtedly be shaped by fire.
Almost every day, gigantic forest fires spark and is a destructive force that nothing seems able to stop.
Un hectare de pinède qui brûle, ça peut être l'équivalent de la puissance d'une centrale nucléaire.
Tens of meters high and spreading over distances that can exceed 500 kilometers, wildfires threaten and destroy millions of people's lives.
I happened to look up and I saw our next door neighbor's trees exploding into flame. Everything behind was completely covered in sheets and walls of flame that 30 to 50 feet high.
Confronting the flames are firemen but also scientists. They reveal the devastating power of wildfire and some of the most unbelievable phenomena, such as firestorms, enormous explosions of flames.
Une nappe de gaz se répand très vite et s'enflamme en quelques secondes sur une très grande surface.
Fire can run over treetops to overtake and encircle its victims. It can create its own wind to gain strength and speed, reaching record temperatures of more than 1,000 degrees Celsius, enough to melt gold. Also, vegetation serve as grenades to spread over hundreds of meters further.
Les pignes sont venues enflammées d'en face. Elles partaient comme des obus.
In order to tackle these powerful fires, firefighters and researchers have created increasingly efficient techniques. But with global warming, fires are increasingly monstrous and destructive.
Le risque d'incendie que l'on a actuellement dans le sud-est de la France pourrait s'étendre dès 2040 à la forêt des Landes et en 2060 à la forêt de Sologne.
So what are these wildfires like? What are their most extreme forms? What tools do they use to gain power? And above all, what does the future hold for us? Can we win the war against the flames? To find out, we go to the United States to study giant fires such as the Station Fire, a fire that destroyed an area the size of an English county.
Alors, on est effectivement sur ce qu'on appelle des méga-feux, à la fois par leur dimension et par leur puissance. Et ces quelques grands feux qu'on appelle des méga-feux sont des feux qui dépassent les capacités d'intervention humaine.
In France, some cities are becoming increasingly threatened by flames.
Nous avons une zone où la nature englobe la totalité de la ville de Marseille. Il est extrêmement compliqué de défendre et les personnes et les biens dans ces zones périurbaines.
In Portugal, we discover an increasingly common phenomenon, multiple outbreaks. These fires of the future see several hundreds of fires ravaging an area simultaneously.
Après, on est très vite impuissant parce qu'il y a tellement de choses qui brûlent par terre et tout que ça va très vite.
Flames as tall as buildings, total destruction of vast areas. Thanks to science, we discover everything there is to know about wildfire at the heart of the flames. Fire. It has always fascinated us, a valuable ally that has today become synonymous of destruction. 40 million hectares of land go up in smoke each year on average. That's the equivalent of Germany and Switzerland consumed every year. In recent years, forest fires have grown to unbelievable sizes. In Chile last winter, over 180,000 hectares were devastated in 2 months by a flame front which reached a width of 500 kilometers. In 2009, Australia saw the most deadly fire in its history. 231 deaths in an area of 365,000 hectares that was completely devastated. The equivalent of Belgium struck off the map. Facing these catastrophes are firemen who brave the flames from the front line, but there are also other firefighters who stay in the shadows and who make major advances against the phenomenon: scientists. They know its most destructive characteristics perfectly, as well as its most powerful allies, and among them, the worst is the wind.
I used to fight forest fires, and we often would say that if the wind was blowing more than about 25 or 30 miles an hour, there wasn't much you could do.
Scientists are doubling their efforts because fire is not like other natural phenomena. It has a very special relationship with man.
Il n'y a pas beaucoup de qu'on appelle catastrophes naturelles face auxquelles l'homme s'interpose. C'est l'une des rares. On ne va pas s'interposer face à une avalanche, un tremblement de terre. Là, sur le feu de forêt, l'homme a la prétention de s'interposer. Donc il est au cœur du dispositif, à l'amont en tant que responsable et à l'aval pour corriger en quelque sorte ses fautes en luttant.
It doesn't take much for a fire to spark in the wild. In scientific terms, it is a phenomenon that relies on a well-known chemical reaction, combustion.
A fire basically needs three things to make it run. It needs an ignition, something that actually sparks it. It needs oxygen to be able to fuel the fire, and it needs fuels, wood or plant material to keep on burning.
The principle is simple. First, it's triggered by what researchers call activation energy. Then an oxidizer, generally oxygen present in the air, burns fuel. In other words, raw material. Activation energy, oxidizer and fuel. These three elements are omnipresent in nature, especially in forests.
Un combustible, en l'occurrence la matière végétale dans le feu de forêt, un comburant, en l'occurrence l'oxygène de l'air, le vent dans le feu de forêt, et une énergie d'activation, c'est une étincelle initiale.
A spark, vegetation and air is all that the flames require. Three types of fire can then arise. Ground fires that burn dead leaves and dry plant residues, surface fires that burn the lower parts of the vegetation, and crown fires which burn the tops of trees. Once triggered, the fire moves faster than a person on foot. Its propagation speed can go over 5 kilometers per hour, with rapid accelerations depending on the landform. However, there is another determining factor in creating a fire: humidity.
L'humidité de l'air, c'est très important pour l'éclosion d'un feu. On sait très bien que dans des zones où on va avoir une humidité supérieure, on va dire à 50%, on va avoir des éclosions difficiles. Mais dès qu'on va atteindre le seuil inférieur à 27-26%, on aura des éclosions de feu très faciles.
Below 26% is a recipe for disaster. It is a scientifically recognized fact. Air humidity plays an extremely important role. It has a direct effect on plants, making them highly flammable.
Lorsqu'on est sur une séquence de sécheresse longue et intense, la végétation, sa teneur en eau va être relativement faible et les plantes vont être d'autant plus combustibles.
Why do plants burn better when they are dry? In cases of severe drought, plants consume water which is contained in their own sap. What remains is evaporated into what scientists call volatile oils, extremely flammable gases. This means that the slightest spark can start a fire. Lots of trees and intense droughts for long periods of time provide the ideal conditions for wildfire. These extreme conditions are very high risk. And unfortunately, these conditions are present in a particular type of climate, the Mediterranean climate.
In Mediterranean climates, the conditions during the spring, summer, even into the fall are incredibly dry. Very low humidities, very high heat.
The heat and droughts in large forest areas make the Mediterranean climate a real tinderbox. This type of climate can be found in very specific parts of the globe.
Alors, c'est un climat dont le nom vient de la Méditerranée, donc les pays du pourtour méditerranéen, mais on retrouve ce type de climat en Afrique du Sud, en Californie, une partie du Chili, et une petite partie aussi de l'Australie.
High-risk zones that exist on almost every continent. And it's in California that one of the worst forest fires in the history of the United States took place, the Station Fire.
Le Station Fire, c'est un record. C'est un record parce qu'on est sur le plus grand feu du comté de Los Angeles.
While parts of the United States enjoy a similar climate to that of the south of France, its forests are beyond comparison. They cover an area the size of Europe. 80% of these forests are in the west of the country, and this is where the largest fires occur. they create what experts call megafires.
Alors, on est effectivement sur ce qu'on appelle des méga-feux, à la fois par leur dimension et par leur puissance. Et ces quelques grands feux qu'on appelle des méga-feux sont des feux qui dépassent les capacités d'intervention humaine.
The name megafire is a purely scientific term. To be classed as mega, a fire must spread over more than 10,000 hectares, an area the size of the city of Paris. This phenomenon is very rare in France, but not in the United States. On the scale of America's vast forests, these fires cover immense regions and can last for months. However, even taking into account the country's extreme cases, the 2009 station fire was out of the ordinary. We are in the heart of the Angeles National Forest, and yet we are in the county of Los Angeles. You wouldn't believe it, but it's just 45 minutes from the center of the city.
Many of course, the attractive qualities of a Mediterranean climate is it's a great place to live. And because of that, you have, I think, within the LA Basin area, somewhere on the order of 7 to 8 million people with a lot of natural areas between those houses, right next to homes.
7 million people, that is a third of the population of Los Angeles, who live in the forests and hills to the north of the city, far from the image of Epinal highways, beaches and built-up areas. It was precisely to live in the middle of nature that Robert and Carolyn settled in the outskirts to the north of the city in Big Jahunga. Today there is nothing left of the couple's property. Everything started on the 26th of August 2009, a few kilometers away from here.
The station fire started on a Wednesday, further up the road, probably, 10 miles or so?
10, 12 miles.
Up the road on Angeles
Up the canyon.
Forest Highway.
It started from people putting out ashes from something that they had burned, and with those dry conditions and the low humidity, it took off.
Just a few embers were enough to light the biggest fire in the history of California. Whether intentional or not, it is man who is responsible for almost all forest fires.
Les feux d'origine naturelle liés aux orages secs, à la foudre, c'est 5 à 10% des causes de feu.
Most often, a fire starts on the ground, on the herbaceous layer, and grows on contact with bushes. From the shrubs, the flames easily reach the lower branches, then travel to the treetops. They call this the elevator effect. At first, the station fire was not very powerful. Experts were not concerned. They thought they had the fire under control and decided to let it burn.
The fire, when it started burning, did not look that threatening. And there is a policy often to, if it does not look like it's going to threaten homes, to let the fire burn as long as it's not in an extreme state.
This may seem shocking, but in Anglo-Saxon countries, the policy is to leave a fire alone, as it is good for some ecosystems. In fact, a large part of Mediterranean plant species could not even reproduce without fire. This is the case of Aleppo pine. In order to reproduce, it must disseminate its seeds, which are contained in its pine cones. The cones are sealed with resin and only open on contact with fire. Wildfire, like all natural phenomena, has a purpose. But the problem is that it also represents an enormous risk for humans. This is what happened in Los Angeles in 2009. While the station fire was still only a small bushfire, control was lost in just a few moments.
Unfortunately, what happened is then the weather conditions did change and the fire really took off and blew up at that point.
In Los Angeles, how did a small bushfire become so uncontrollable in just a few moments? It was thanks to the fire's best ally, wind. And not just any wind. In California, the most dangerous wind is called the Santa Ana.
The Santa Ana winds occur usually during very dry conditions when the temperature is still quite warm, often about 100 degrees. And the winds come from the east. They blow up over the mountains and out towards the coast. And they're very strong winds, often 50, 60-mile-an-hour winds.
The Santa Ana is the equivalent of the Mistral wind in France, but worse because it is dry. It comes directly from the desert. And the problem is that the fire's speed of propagation is directly linked to the speed of the wind.
Le sinistre progresse à 3% de la vitesse du vent. Donc effectivement, vous pouvez imaginer que pour un vent de 100 km/h, le feu peut se propager à 3000 mètres par heure.
3,000 meters, that's 30 football pitches in an hour. On that day in Los Angeles, the power of the fire escalated very quickly. It then moved westward.
So it jumped the highway up there and started burning down canyon towards us.
The fire even managed to cross the highway, and it's the wind that is responsible, as it caused what scientists call fire jumping.
Le vent peut transporter des particules incandescentes qui vont pouvoir allumer des sautes de feu en avant du front de flamme principal.
Burning twigs are transported by the wind across the road and burn the vegetation on the other side. These multiple fire jumps create so many new fire lines that they must be fought before they develop. The firefighters did not manage to extinguish them all. Although the wind speed slowed down, the fire continued its wild course. And even with the wind lessening, the flames drew closer to Robert and Carolyn's home. In 2 days, it traveled 30 kilometers, arriving at the top of the canyon where the couple live. Why such a fast pace when there was no wind?
No wind whatsoever, just a very warm day. And as we were standing there, a 50-mile-an-hour wind came from down canyon upward.
What Robert and Carolyn noticed was a phenomenon that scientists know very well. It was actually the fire itself that produced its own wind. To burn, the fire seeks to consume all available oxygen. It produces a suction effect, like a giant vacuum cleaner, creating its own wind to fuel the flames.
Il y a un phénomène d'aspiration de tout l'air frais alentour, et notamment devant le front de flamme, qui génère des vents au sol qui peuvent être vraiment importants.
Once started, the fire no longer needed wind from the outside in order to advance. Robert and Carolyn did not immediately realize the gravity of the situation.
As I was coming outside, loading possessions into our horse trailer, one of our neighbors came running up and said, "You've got to get out, you have 5 minutes left." At that same moment, I happened to look up and I saw our next door neighbor's trees exploding into flame. Everything behind was completely covered in sheets and walls of flame that 30 to 50 feet high.
It was a full-blown emergency. The fire, which until then had been running along the ground, reached the treetops, the canopy.
Called a crown fire, and generally crown fires, when they happen in forests, it's a very dangerous situation to be in. The fire literally can run right over the top of you.
The flames move from tree to tree with increased power and speed as they are fueled by the enormous quantity of leaves.
Dès que le feu passe dans la strate arborée, devient un feu total, ce sont des feux qui ne sont plus contrôlables par les moyens humains.
For the couple, there was only one solution: to flee. Robert and Carolyn each leave in their cars, following one another, when suddenly Robert, who is in front, can no longer see his partner in the rear-view mirror.
I became very panicked. I wasn't sure if I should get out of the truck and run back, but I also realized if I were to get out of the truck, I would probably burn up.
And with good reason. The heat is tremendous. Indeed, when burning, plant life specific to the region produces record temperatures.
If you were burning a shrub that was not one of these chaparral species, it might have a temperature of 200 or 300 degrees Celsius when the fire burned. Temperatures in chaparral communities with these fire-dependent shrubs have been measured at 1,000 degrees.
1,000 degrees, that's gold melting temperature. Why such heat? Scientists discovered that these plants actually need fire and contain highly flammable gases. When they catch fire, these gases, called pyrophytes, raise the thermometer up to 5 times the temperature of an average fire. Luckily, Carolyn quickly joined her partner and they drove at breakneck speed at the heart of the fire. After a few hundred meters, Robert and Carolyn managed to get out of the canyon, finally leaving the blaze behind them. But the impact is catastrophic for the couple and their neighbors. No less than 50 houses were completely destroyed by the flames. Nearly all of the vegetation was devastated. So what explains such a level of destruction? The answer is simple yet surprising. It is by wanting to limit risks at all costs that we have created the conditions for these mega fires that destroy everything.
common problem that we now have in California and actually in all these Mediterranean climates is because of the danger of fire, people have put out fires.
And by preventing fires from regularly clearing the forests of bush and deadwood, we have created an enormous reservoir of fuel.
And because of that, when the fire does get in there and burn, it burns very, very hot. And if it burns hot enough, the fire will move out of just burning on the surface where it used to just kill the smaller trees. It will burn up into the crowns of the trees.
For scientists, this type of fire is categorized as a total fire. The heat which is emitted causes the trunks to burn, which normally resist flames, and the fire therefore climbs up to the treetops. Absolutely everything is destroyed. Total fire is a terrible disaster, but there is worse, what scientists call firestorms. This phenomenon occurs when the famous flammable gases released by plants are trapped in a natural basin.
Donc il y a un phénomène d'accumulation au mélange détonnant qui, d'un seul coup, prend sur une grande nappe.
The gases are trapped by the natural landform, and when the concentration of gas is very high, everything explodes almost instantaneously. Luckily, there was no firestorm in Los Angeles in 2009, but the giant fire continued its progression towards the city center. Yet a few kilometers away, still nobody suspects the magnitude of the drama. Kathleen Sutherland lives less than 20 minutes away. For her, that day was fairly normal.
I heard about it on television, and at that time I wasn't worried. It was way that direction, so I wasn't thinking about it. I would drive home from work, I would come up the freeway, I could see some smoke down there. I never thought too much about it.
However, the fire continued to spread and drew closer to dense residential areas. So the county's 3,000 firefighters took things into their own hands. They ensured the safety of more than 3 million people spread over an area of 12,000 kilometers. And to fight the station fire, they received help from all over the country. Despite the incessant whirring of helicopters and the tremendous human resources deployed by the authorities, nothing succeeded in stopping the flames. The firefighters decided to attack the fire's basic elements. Remember that once it's alight, fire needs oxygen and fuel. And as it is impossible to deprive it of oxygen, it must be deprived of fuel, that is, of wood.
Well, the main way of fighting against fire in natural systems, both shrub communities and in forests, is to really eliminate the fuel. And the main way that that's done is either creating a trail, a break in the fuels around the perimeter of the fire.
To be sure that the trenches were wide enough to avoid fire jumping, the American firefighters used bulldozers. They went even further, lighting fires against the flames themselves. This is what experts call backfiring.
We now fight fire with fire, which proves to be very effective in that you can get out in front of the fire, light a fire, and let it slowly work its way back towards the wildfire, burning all of the fuel out so that when the wildfire gets to that point, it doesn't have anything to burn anymore.
The technique of backfiring is particularly effective, but it needs to be used in advance and it takes time. And time is exactly what the Los Angeles firefighters were lacking in September 2009. The fire was on the outskirts of the suburbs. Nearly 10,000 homes were under threat.
Each day, as I was coming home, the smoke was coming closer and closer. So when the fire started to get really close, then I became frightened. And at that time, we got a phone call from the city of La Crescenta, and they said that we were on standby for evacuation because the fire was coming to our house.
In the end, nearly 25,000 people were evacuated. For the 5,000 mobilized firemen, the fight continued for many weeks. Finally, only the arrival of rain could put an end to the station fire, considered permanently extinguished on the 16th of October, almost 2 months after it started. The impact of this giant fire was substantial. More than 200 buildings were destroyed and an area of 65,000 hectares went up in smoke, the equivalent of a country like Singapore. An indirect consequence, the loss of vegetation on the hills around the city led to landslides and mudflow during the rains the following winter. This is for the giant fires in California, but what happens when a fire starts in France? While in France fires are common in summer, they are much less extensive than the station fire.
Le station fire, la surface totale de ce feu, 65 000 hectares, c'est la plus grande surface jamais atteinte en France sur une saison feu complète.
Megafires, are they possible in France? For a fire to be considered mega, most experts consider that it must exceed the threshold of 10,000 hectares. This has happened only once in France, in 1990 in Villeurbanne, in the Var, where vegetation fires stretched 11,580 hectares. But experts do not rule out this possibility, far from it.
On dispose des forêts qui permettraient d'avoir à terme ce type de feu. Par exemple, la Corse est une île extrêmement combustible. Il n'est pas exclu qu'un incendie en Corse aille d'une côte à l'autre.
And while megafires are not yet a reality in France, the country has seen some particularly dangerous fires in recent years, as flames have reached the gates of cities. France is covered by 16 million hectares of forest. While only 1/3 is considered by scientists to be susceptible to fire, that still represents 10% of the entire country. What's more, this type of forest is concentrated in one region, the southeast. The capital of this region is Marseille. The city is the country's second largest with a population of 900,000. It is surrounded by several mountains, nestled between the sea and the forests, an ideal position if there were no forest fires. At the end of July 2009, Marie Consenot was living in the Trois Ponts area, in the east of the city.
C'était un été normal, hein? On a eu du beau temps, on a eu de la chaleur, on a eu de la pluie un peu, mais non.
But a normal summer in Marseille, in full Mediterranean climate, is already a dangerous situation.
Donc, le climat méditerranéen, c'est à la fois des températures importantes pendant la saison estivale et surtout une forte sécheresse. Une sécheresse qui dure pendant 2 ou 3 mois pendant la période estivale.
And during the summer of 2009, in 24 hours, everything changed. The fire found itself at the doors of Marie's home, a moment that will never disappear from her memory.
On a peur, on a toujours peur. Dès que je vois un hélicoptère tourner autour de la maison et des alentours, je dis toujours il y a le feu quelque part, quoi. Hein?
On the 22nd of July, less than 10 kilometers away from the city, a fire started in the Capillon military camp, sparked by a gunshot during training. At first, only a few bushes were on fire, but during summer in this region, the smallest spark can trigger a disaster.
En plein été, on arrive à des températures supérieures à 30 degrés Celsius. L'humidité de l'air va être réduite à 15 voire 18%. Et puis, on a malheureusement également un vent qui va activer donc l'apport d'oxygène sur ce feu.
Remember, the situation becomes dangerous below 26% humidity, so below 20%, the conditions are extremely volatile. Droughts force plants to tap into their water reserves to survive. They then release highly flammable gases. Worse, the plants of the Capillon area are very special. It is not really a forest, but a scrubland.
Ce sont en général des arbustes et des herbes qui forment un ensemble de couches de végétation relativement basses. Ces plantes de la garrigue sont particulièrement bien adaptées au feu.
Bush and shrubs make up the scrubland, and to burn these plants, the fire needs a lot less energy than to burn trees. It is like in a chimney. Smaller wood burns more easily than logs, so fire goes a lot faster. That day in Capillon, the fire travelled 7 hectares in 1 hour, and on top of that, the wind was blowing. In summer, the wind in the Côte d'Azur is a firefighter's worst nightmare. Corvette Captain Priol is a naval firefighter for the city of Marseille. On that day, the 22nd of July, he took command of the operations.
Le sinistre progresse à 3% de la vitesse du vent. Donc effectivement, vous pouvez imaginer que pour un vent de 100 km/h, le feu peut se propager à 3000 mètres par heure. Et 1 hectare de pinède qui brûle, ça peut être l'équivalent de la puissance d'une centrale nucléaire.
Remember, once the fire is activated by a spark, it is oxygen from the air which burns the fuel, that is, the vegetation. The more wind there is, the more air and oxygen there is, and the faster the plants are burned. But in July 2009, the wind blowing was not the same as usual.
En règle générale, la ville de Marseille est soumise à un régime de Mistral. Et ici, nous avions un vent de sud-est, effectivement. Donc ce type de feu, nous ne l'avions jamais rencontré.
The Mistral is a wind which can reach unbelievable speed and make fire uncontrollable. However, for the firemen, the fact that it was not the Mistral blowing on the 22nd of July 2009 was anything but good news. This is because the Mistral is a wind from the northwest, and that day the wind was blowing in exactly the opposite direction. In short, rather than blowing the fire away from Marseille, it brought it towards the city and its hundreds of thousands of inhabitants. If the flames reached the city, the disaster would grow to cataclysmic proportions. For the firefighters on the ground, the stakes were high and the pressure was tremendous. The situation was very dangerous. The landform made movement very difficult. The wind and the dry scrubland allowed the flames to rage.
Fire really blows up. In fact, it will move so fast at that point that in many cases, firefighting forces will pull back because it's very dangerous to be in that kind of condition.
The situation was all the more dangerous because the fire was not moving in only one direction. It grew wider as it advanced. The firefighters risked being surrounded by flames at any moment.
Le feu, c'est pas un point qui se déplace comme un homme à une vitesse qui peut sembler relativement raisonnable, mais c'est un front qui s'étend, avec une tête de feu qui va relativement vite, mais aussi des flancs qui s'élargissent.
The fire moved with the wind. It was the wind which gave the flame front its general direction. What's more, as the fire was fed by the plants that it burned, it went everywhere where it could find fuel. The result was that as the front moved faster, it also expanded from the sides. While the fire brigade managed to contain the flame front, the flanks continued to advance and move beyond them. On the ground, the firemen had to be careful not to get trapped, and that day they lost ground. For Captain Priol, giving up was out of the question. Marseille had to be protected at all costs, so he called for aerial support. From the outset, the closest civil security base was warned. Olivier Le Chevalier is a seasoned pilot who has worked on more than 1,000 fire missions. He was the one who directed the aerial action against the fire of Capignan from his Canadair.
Dès le départ, c'est une course contre la montre, puisque quand le feu est vraiment établi à cause des facteurs aggravants, l'hygrométrie, la force du vent, la température, la sécheresse, eh bien, c'est tellement puissant que nos moyens, même si on avait double ou triple moyen, on ne pourrait pas l'éteindre.
It is all a question of timing. Every minute counts in the fight against fire.
Votre panière à papier prend feu, avec un seau de 10 litres, vous allez l'éteindre. Maintenant, si la panière à papier a mis le feu au rideau et puis à toute la maison, c'est plus 10 litres qu'il va falloir.
The aerial fight began in the Capignan Mountains. The Canadairs do not simply drop their 6,000 litres of water to put out the fire. They try to spread a chemical product in front of the fire. This product is called a retardant and is mixed with water.
Il a pour avantage de rendre plus efficace la pellicule humide qui recouvre la végétation.
Developed by scientists and composed of special salts, polyphosphate salts, this product makes plants much more fire resistant. To succeed in burning this vegetation, the flames must reach 700 degrees rather than 200 without the retardant.
On va enrober la végétation de ce produit, de ce sel. À l'arrivée du front de flamme, le front de flamme va, comme on dit, pomper de l'énergie en fait pour essayer de brûler cette végétation et ainsi va perdre de sa puissance.
But for this technique to be effective, it must be monitored. This time in the Capignan Mountains, with factors such as drought, wind and the landform, there is almost no visibility. The fire brigade and the pilots must work in the heart of the smoke. The smoke makes the work of the Canadairs a lot less effective and risks the lives of their teams.
Si jamais ils n'ont pas une visibilité parfaite, si jamais ils n'ont pas l'œil sur les différents obstacles, on risque des accidents.
On évolue très très près du relief, donc la moindre inattention, à 10 mètres près, on peut accrocher un arbre.
Especially in high doses, the smoke generated by wildfire can be toxic because it contains carbon monoxide, vapors and irritating gases. Consequently, the smoke disorients very quickly and can cause severe asphyxia and discomfort. As the flames got dangerously close to the city, water bombers could no longer be used to avoid injuring the inhabitants. No more planes as the fire approached the gates of Marseille. The city had to be protected at all costs. Captain Priol decided to reposition his men around the closest residences, which risked being reached. It was 6 o'clock in the evening. The fire arrived at the La Valbarre district, then descended along the outskirts of the city. At the height of the crisis, 1,000 men and 300 machines were mobilized, as, according to experts, several zones could be affected at the same time. The inhabitants were taken by surprise.
J'étais de sortie, donc j'ai pas fait attention que la colline brûlait. C'est quand j'ai vu le feu en haut de la butte que j'ai compris qu'il y avait le feu qui arrivait sur les 3 ponts.
The Trois Ponts area is a series of cliffs covered in vegetation which hang over its narrow streets, with a very concentrated population. The fire brigade arrived, but the task was complicated. The trucks had trouble moving around, and there were few water sources.
Le feu descendait sur les maisons, donc on s'est mis en position de protection avec des lances. On se met en appui sur les maisons pour se protéger nous aussi, parce qu'on ne va pas s'exposer dans la pinade avec des flammes qui descendaient rapidement.
By spraying the flames, firemen seek to harness the powers of 2 scientific phenomena. First, they try to lower the temperature of the fire. Below 300 degrees, wood does not burn. To do that, they project water as widely as possible. The second scientific phenomenon is even more surprising. The heat transforms water into vapor, and this vapor, which is a gas, replaces the oxygen, and without oxygen, the fire can no longer burn. This technique is very effective, as a single litre of water brought to 100 degrees produces 1,700 litres of water vapour. But for this to work, large quantities of water are required, which was unfortunately not the case in the Trois Ponts area. In Marseille, hours passed, the fire did not weaken, and the firemen continued to struggle.
On retient son souffle. On évite de respirer tellement on a peur. Et puis on voit le feu s'éteindre, alors là, hop, on respire un bon coup, on se dit bon, ben c'est pas pour cette fois. Je dois reconnaître que les pompiers ont fait ce qu'il fallait. Hein.
Although the firefighters could not extinguish the fire, they at least succeeded in channeling it and preventing it from reducing the Trois Ponts area to ashes. The fire stopped 50 centimetres from Marie's house. But the fight was not yet over. Despite nightfall, the weather did not help.
Alors, en général, à ce moment-là, on a des conditions météorologiques qui deviennent plus clémentes avec la tombée du soleil, la température baisse et souvent on a l'humidité de l'air qui réaugmente un petit peu et parfois le vent qui baisse, mais ce n'est pas toujours le cas.
By the end of July 2009, contrary to expectations, the wind did the exact opposite.
Il a eu la particularité d'être au niveau de 13 heures aux environs de 40 km/h. Et ensuite, pendant la nuit, alors qu'en règle générale, le vent a tendance à se calmer, là, il s'est renforcé.
The danger was increasing for the firefighters, who no longer had aerial support and whose visibility was very limited. The wind was growing increasingly stronger and the fire raged. It continued its wild course in the direction of the La Panouse district. And it is here that it did the most damage. It was nearly 2 o'clock in the morning. The fire was raging on the slope next to the neighbourhood, a slope covered in pine trees. However, pine has a very special behaviour during fires, a behaviour which makes it a very effective ally for the fire.
Le pin est un client de choix pour le feu, parce qu'en été, en fait, sa teneur en eau est très faible, donc il est très combustible, mais également, on observe le long de son tronc des coulées de résine très inflammables. Et le courant de voir le feu monter, j'allais dire, dans l'arbre grâce à cette résine.
Pine is a species which has developed with the help of fire. It uses it to spread its seeds contained in the pine cones. In fact, the pine cones are sealed shut by this highly flammable resin. Scientists discovered that on contact with heat, they burst, opening up and spreading their seeds over a large area.
Les pines de pin, quand ils vont s'enflammer, souvent ces pines vont éclater et vont être projetés alors à des dizaines, voire des centaines de mètres.
On the night of the 22nd of July 2009, this is exactly what happened to the colonel.
Les pignes sont venues enflammer d'en face. Elles partaient comme des obus. Alors c'est rentré, ça, bon, d'abord une, puis deux. La maison ne s'est pas enflammée tout de suite, puisque des voisins nous ont dit on a d'abord vu sortir de la fumée de chez vous.
The colonel's home faced the pine forest. The pine cones were projected with such force that they easily got into the house.
J'avais une véranda ici avec une baie vitrée. C'était pas des doubles vitrages, c'était des vitres simples. Hein. Bon, c'était facile de passer à travers et avec les tapis, les meubles, tout ça.
Oui, tout.
Toute ouverture, une fenêtre laissée ouverte ou un volet qui ne serait pas fermé et une vitre qui explose sous l'effet de la chaleur. Et dès qu'il y a cette ouverture, les particules incandescentes vont rentrer en masse dans la maison et allumer tout ce qui peut être combustible dans une maison, que ce soit le tissu d'un fauteuil, un rideau. Et quand ça se voit, c'est trop tard.
The next morning at 8 o'clock, the fire was finally stopped from spreading further, but it took another 4 days for the fire to be considered officially extinguished after having burned 1,000 hectares of land. This delay after the visible suppression of the fire is due to an astonishing phenomenon, root fires.
That fire actually follows where it has fuel, and so it will follow down into the ground and burn along the roots of the trees. And then if the weather conditions change and become favorable again for the fire to spark up, all of a sudden it may come back up again, and the fire that you thought you had out will start burning again and making a new run.
Once extinguished, the fire left behind charred trunks and scorched branches. These scars give an indication of the severity of the damage caused, but also of the chances of survival of the trees. Because certain species have developed special forms in order to resist fires. With its very thick bark, oak cork protects the living tissue of its trunk from heat. Other trees grow quickly to gain height and escape the flames. Sometimes they even naturally prune themselves by getting rid of their lower branches. After a fire, however, survivors are weakened for several years. Some trees never grow again. But some species deploy strategies to rise from the ashes. This is the case with most hardwoods that are capable of growing new branches from charred trunks. As for the majority of softwoods, they regenerate when the seeds that they have released germinate after a fire. For the Colonna, this fire was a disaster, but the damage could have been a lot worse. Firefighters managed a remarkable operation in the protection of Marseille from the flames. But unfortunately, fires threatening cities are likely to become more and more frequent. These giant fires are causing increasing damage all over the globe. Scientists are worried for the future. But why are forest fires becoming bigger and more destructive? What does the future hold for us? Experts consider the likely evolution of these disasters can already be observed in one European country, Portugal.
Au Portugal, on est déjà dans un phénomène qui est l'étape d'après, qu'on connaîtra peut-être, je n'espère pas, mais peut-être en France dans les années à venir, qui est ce phénomène de grands feux simultanés. Quand on regarde les images satellitaires de ces dates, on voit plusieurs colonnes de fumée, visites de satellites, qui partent du Portugal continental et qui vont jusque assez loin sur l'océan Atlantique. C'est vraiment impressionnant.
Fernando Ribeiro is from Portugal. During the summer in his village, fires have become incredibly common.
C'est un truc qui vit avec nous tous les ans, il y a un feu. C'était normal. Je me rappelle de passer en voiture à côté de feux où on sent la chaleur vraiment, même à travers les vitres et tout. On entend souvent les pompiers, on voit la fumée au loin. C'est un truc qui est complètement habituel.
Fires in Portugal are nothing new, but these last few years, the numbers have soared. In 2016, 160,000 hectares were consumed by flames. That's nearly 3 times that of the station fire in Los Angeles. And the worst is that hundreds of fires can start at the same time, all over the country. The Portuguese climate is very similar to that of the south of France, and the plants have similar origins. Yet this country sees the number of its forest fires continuously increasing.
Entre 2003 et 2005, 2 saisons catastrophiques de feu au Portugal. Le Portugal brûle 23% de sa surface forestière. C'est absolument énorme.
A quarter of Portugal's forests, the size of Corsica, has gone up in smoke in 3 years. So what explains this magnitude? To understand, one only has to look at what happened in this country during the summer of 2016. On the 8th of August 2016, 35 fires raged around the city of Porto, while about 100 fires ravaged the north of the country. And the fire went beyond the limits of the city, unlike in Marseille. This time it entered the city of Funchal and almost destroyed its historic quarter.
Et quand on voit l'ampleur des dommages, 110 maisons détruites, plus de 200 installations impactées, ça témoigne d'un nouveau type de feu auquel il faut faire face, auquel il faut se préparer.
For a large city to be partly destroyed by wildfire in Europe. This had never happened before, so what happened on the 8th of August? The summer of 2016 in Portugal was marked by intense heat and drought, even more than usual. In recent years, southern Europe has experienced warming which makes the weather conditions more and more extreme. Unfortunately, perfect conditions for forest fires.
Tous les facteurs finalement vont dans le même sens, à la fois l'augmentation des températures qui augmente le risque et aussi l'augmentation des conditions de sécheresse.
Another factor was added to these very dangerous conditions, a factor that changed everything.
Il y a eu notamment un épisode, on peut résumer par un épisode de type sirocco, avec un vent très chaud venu du sud, venant d'Afrique du Nord.
Once again, it is the wind which turned the situation into a nightmare, and not just any wind, the sirocco wind. Characterized by intense heat and dryness, it originates in the heart of the Sahara. When it blew over Portugal on the 8th of August, the slightest spark caused many disasters.
Foi quase uma cena de terror.
My mom is screaming, my dad is crying.
Aquilo está de uma tristeza. Está até assim.
Leave your house, be careful because the fire is in your house.
That day on the island of Madeira, a fire started just outside the regional capital, Funchal, and burned a large part of the historic quarter in just a few hours. How? In fact, the fire was carried to the heart of the city by a highly flammable species of tree, the eucalyptus.
Moi, j'ai toujours connu les eucalyptus. Il y a un petit peu de sapin, il y a un petit peu de chêne, mais c'est surtout l'espèce qui pousse le mieux.
Eucalyptus is a species found all over Portugal, but it is not originally from this country. It comes from the other side of the planet, Australia.
L'eucalyptus australien a été planté au Portugal par des industries papetières pour faire du bois énergie ou du bois d'industrie.
Eucalyptus and fire have a long history. In its home country, it is the cause of immense fires which run riot every year during the dry season. Its characteristics, well known to experts, make it a very good ally for fire. Fernando knows something about this. He fought the fire at the gates of his village.
C'était au mois d'août. On était en vacances avec des amis qui étaient venus à la maison et ça s'est déclenché tout à côté de la maison, à 300 mètres de la maison.
Fernando went immediately to the scene. He noticed that the leaves and pieces of eucalyptus bark covering the ground were the prey to the flames.
Il y a le feu qui s'élargit, on tape dessus, là où quand il y a une flamme, on tape dessus pour l'éteindre et la calmer. Après l'extincteur, j'ai réussi à éteindre des foyers un peu plus importants, mais après on est très vite impuissant parce que il y a tellement de choses qui brûlent par terre et tout que ça va très vite.
Scientists know that eucalyptus leaves decompose very slowly. In summer, this very dry bedding that covers the ground is just waiting for an opportunity to ignite. Fortunately, the firemen arrived very quickly. Fernando was lucky. But in the city of Funchal in 2016, it was another of the eucalyptus's characteristics that triggered the disaster.
La particularité de l'eucalyptus quand il brûle, c'est de produire des morceaux d'écorce, des lambeaux d'écorce. Et ces particules incandescentes, ces écorces qui brûlent, ont pu être transportées sur plusieurs centaines de mètres.
The shreds of bark are very light. Remember, pine cones explode on contact with fire and are projected a few tens of meters. With eucalyptus bark and leaves, it's much worse. The distance can reach hundreds of meters. Driven by the wind, the burning bark landed in the middle of the city, sometimes even in houses with open windows. These buildings immediately caught fire.
Il faut imaginer une pluie de cendres incandescentes, donc qui tombe au hasard sur tout un périmètre, et puis une maison abandonnée, vitres cassées, porte ouverte, la ruine prend feu et les maisons alentours sont menacées.
For locals and tourists, the situation is catastrophic. There is smoke everywhere.
L'air est très vite asphyxiant, c'est poussiéreux partout, c'est étouffant.
That day, Funchal was on the brink of chaos, especially since the island of Madeira is 1,000 kilometers from the rest of Portugal, making it impossible for reinforcements to arrive. In the end, the city owed its salvation to a change in weather. The wind eventually dropped and the moisture went up, which stopped the fire. But in the rest of Portugal, the fires continued for weeks. And with global warming, we risk knowing more and more of disasters like those that ravaged Portugal during the summer of 2016.
On fait déjà le constat que les feux de forêt augmentent et on fait même l'attribution, dans certaines études, de l'augmentation de ce risque de feux forestiers avec le changement climatique.
In France, the current upheavals are irreversible and risk changing many things.
Dans le cas de la France, on fait le constat que le risque d'incendie que l'on a actuellement dans le sud-est de la France pourrait s'étendre dès 2040 à la forêt des Landes et en 2060 à la forêt de Sologne.
La Sologne, just outside of Paris. The situation is likely to be all the more disastrous as the forests of the northern half of France are populated by species of trees which are not adapted to fire and which therefore risk not being able to regenerate. This also means that prevention and control plans will have to be thoroughly reviewed.
Il faut vraiment réagir pour ne pas devoir gérer des situations catastrophiques du type du station fire, mais cette fois-ci en Europe.
For scientists, the extension of the concerned area is not the only effect of global warming. It is already occurring during wildfire seasons, and this is everywhere on the planet.
When fire season in the past used to start, let's say in Los Angeles, it would start roughly around May and be hazardous all the way into October. We're now seeing those fuels and that condition dry out in March and April, sometimes even early March.
In recent years, the number of forest fires has already seen a sharp increase, so much so that according to some studies, they are responsible for 20% of greenhouse gas emissions. They participate in global warming, which in turn multiplies forest fires. Another cycle has begun, which is no longer natural.